So first of all, welcome everybody. Here we are, Hughes Center for Agro-Ecology is very excited and happy to release this study today. The technical study on changes in forests and tree canopy in Maryland has been a project we've been working on for several years, and we think it's outstanding in some of the implications it has for the state. So in terms of both progress we've made and opportunities. So forests represent one of Maryland's most important natural resources. They're critical to our economy, to the environmental sustainability of our state, as well as to the health of our citizens. And because of this, forest conservation and tree planting are central strategies have been recognized as central strategies to achieve the goals of the 2014 Chesapeake Bay Watershed Agreement. In order to monitor forest and tree canopy cover in the state, the Maryland General Assembly passed in 2019 Senate Bill 729, and then the language was repeated in House Bill 991 in 2021, and it required the production of a technical study of changes to Maryland's forest and tree canopy. So to satisfy the provisions of those bills, the Hughes Center for Agro-Ecology first conducted listening sessions with stakeholders throughout our state. And then we issued an open request for proposals and went through the process of accepting proposals, having them peer reviewed by technical experts in this area. And following that review process, the Chesapeake Conservancy and the University of Vermont were awarded. They submitted a proposal and were awarded that grant based on the excellent reviews from subject matter experts and scientists. And you will hear from them. The Chesapeake Conservancy and University of Vermont were responsible then for developing information on most of the sections of this legislation, and you'll hear from them in just a minute. I want to recognize that you'll hear from Susan Minnemeyer from the Chesapeake Conservancy. The PI on that grant was actually a co-PI was Jarlath O'Neill Dunn at University of Vermont, also very involved, but he wasn't able to join us today. So in addition to the work of the Conservancy and University of Vermont, there were two additional sections of the legislation that were completed by Dr. Addie Dubé of the Hughes Center, and you'll hear from her a little bit later in this presentation. Her work completing those two sections followed preliminary work of Russ Brinsfield interns that we employed here at the Hughes Center, named Harry Huntley and Maeve Kessler, and I also want to recognize their contribution. So before we get into the presentation, I want to thank our advisory committee as well as the legislature. The advisory committee that we put together at the beginning of this process included representatives from the Department of Natural Resources, Maryland Department of the Environment, Maryland Department of Planning, Maryland Department of Agriculture, the Chesapeake Bay Program, and the Chesapeake Bay Commission. Their expertise was really critical and helpful in helping us both plan the process and develop the report. And I really think that our report is much improved because of their expertise. But I want to mention that while they did provide advice over the development of this work, the views expressed in this webinar are really those of the speakers and not necessarily of the advisory committee. The second group that I want to thank are Maryland's legislators. We're really grateful that they had the foresight to sponsor this legislation and call for this report. They recognize that we're really at a pivotal moment in Maryland as we go forward, trying to meet goals to address so many global issues that we have here. They decided that it was time to evaluate the progress of previous legislation. How were we doing in terms of meeting goals of that previous legislation, including the Forest Conservation Act? And again, as I said, it's really a pivotal time as we try to go forward and meet the goals of new legislation like the Tree Solutions Now Act. So the study is timely and valuable. And I think you will see that it highlights our progress, but it also identifies opportunities to improve both the extent of our forests, their health, and forest connectivity. So with that, we'll go to our first speaker. Susan Minnemeyer joins us from the Chesapeake Conservancy in Annapolis, Maryland, where she serves as the Vice President for Climate Strategy. She's leading their efforts to accelerate the development of nature-based climate solutions for the Chesapeake Bay watershed that build on our region's rich and deep expertise in ecosystem restoration. Prior to serving in this role, Susan led the Chesapeake Conservancy's Conservation Innovation Center for 2 years, and she also has over 20 years of experience related to forest monitoring, including that she served as the Senior GIS Manager for the Forest Program at the World Resources Institute. So with that, I'll hand it over to Susan.
Okay, thanks, Kate. Actually, first, I'd like to invite our Executive Vice President of Programs, Mark Conway, who's going to say a few words and some opening remarks with the study. And then from there, I'll go into our key findings. So, Mark.
Awesome. Thanks, Susan. And thank you, Kate, for all the partnership that you provided in this work as well. Once again, my name is Mark Conway. I'm the Executive Vice President of the Chesapeake Conservancy. Really happy to be here because this is a foundational moment, this forest study. For the first time, we'll have the opportunity to look at forest cover change for the entire state of Maryland. For the first time, we'll be able to assess our tree planting efforts and our forest protection efforts to really see how they're working. For the first time, we are able to confirm that the rate of forest loss has declined over time, which is a really important step in the right direction. However, I think we also are able to confirm that we've seen some counties still saw very significant forest loss. And this study really helps us begin to understand some of the reasons why we're seeing that. We'll also have the opportunity to talk a little bit about some of the policy solutions and their relative success. I think we can all agree here that information is power. And as our state works to restore the health of the Chesapeake Bay and deals with the effects of climate change, utilizing the latest high-resolution land cover data to study forest and tree canopy is one of the most important valuable tools in our toolbox. Trees are our best protectors from storm surges, floods, sea level rise, extreme temperatures, and they play a major role in water filtration and stormwater mitigation, air pollution removal, climate resilience, and carbon sequestration. Trees are one of Maryland's most important natural resources. In fact, our health, our environment, and our economy all depend on trees. And this study is an important tool that state and county policymakers can leverage to improve Maryland forests and finally get us to stability or a no net loss in forest cover. So really excited to put this forward today. And with that, I'll hand off to Susan.
Great, thank you, Mark. So our goals in conducting this study were to collect and analyze a broad array of information, organize and distill the results to identify key insights, and also to make a wide array of information transparent and accessible to experts and stakeholders interested in using this information to enable data-driven decision-making across the state. So with that, I'll get into our key findings and the scope of the study. We were looking at 7 key tasks that were identified in the legislation that funded the study. First, we looked at forest and tree canopy extent. How much forest does Maryland have? How is it changing? And also what opportunities there are for forest restoration and tree planting. We looked at forest health through the lens of fragmentation and invasive species to see what key trends we could identify in this area. We looked at progress for Chesapeake restoration through the Chesapeake Bay program, looking at the tree-related conservation practices that goals have been set for, namely looking at urban tree canopy and progress in planting riparian forest buffers. On the topic of forest and tree canopy change, we took a deep dive into patterns of change across the state, both in forests and tree canopy outside forest, what further changes are projected, and other key drivers of change. On the progress side, we looked at tree planting programs and forest protection, what progress has been made in these areas, as well as what is planned for the future. And then the last two tasks on mitigation banking related to the Forest Conservation Act and forest and tree planting programs. I'll pass it over to Dr. Dubé at the Hughes Center for an overview of the key findings in those areas. So starting with the data sets used in the study, we focused on using 3 different data streams that are short to long-term monitoring products that are independently produced and independently managed, and identifying if we could find similar key trends or key differences using these data sets. So the data products used for the study, first of all, are the USDA Forest Service forest inventory and analysis data. This is field collected data at sampling sites all over the United States. It's been ongoing for nearly 90 years, and it is probably, the world's most advanced forest inventory data set. It's highly reliable, but there are some shortcomings for doing a statewide analysis, and namely it's that because of the sampling density, you can get state totals, but it's not possible to get local statistics on county and regional patterns. So when getting into more specific local patterns, we're using 2 data sets that are derived through remote sensing. First, the National Land Cover data set, which is produced by the MRLC, which is a consortium of federal agencies. It analyzes data from the Landsat satellite, which is 30 meter by 30 meter pixels. It's considered moderate resolution data. And there's data available from the 1990s to the present, but we use the key data streams available from 2001 to the present for this study because they had all of the metrics we were interested in using. And then finally, we analyzed the high resolution Chesapeake Bay program data, and this is the data that Chesapeake Conservancy produces in partnership with the University of Vermont Spatial Analysis Lab and the USGS. It's based on USDA NAEP, that's the National Agricultural Imagery Program imagery, which is imagery collected by airplane, and high resolution LiDAR data, which gives us detailed information on vegetation height. And this data set, we released the very first change products earlier this year. It covers a time period of 2013, 2014 to 2017, 2018. So with these 3 data sets, we get a combination of long-term statistical data, moderate resolution, medium-term data, and more recent high-resolution data. Also want to note that because of the resolution, the 2 maps that are shown on the screen for the NLCD and CBPO data sets compare what you can see in a focal area. With the high resolution data, we get much more detail on specific tree canopy and forest coverage in urbanized areas and change in those areas. Some key definitions for the study are understanding what we mean by land cover versus land use. Land cover is really describing the view of the earth from above, what you might see from an airplane when you're looking at the landscape below. You see forest cover, tree canopy cover. You may not be able to tell precisely what every portion of land is being used for, but you can see those broad classifications and changes. And then land use is really getting into how people use the land. And with the high resolution data set, we collect a lot of data sets from state and county jurisdictions on land zoning, so we can pull out which of the land is being used for growing crops versus pasture versus lawn and turf. And then we also classify, more importantly, what part of the landscape is forest, which is the dark green color on the screen, and then what tree canopy is outside forests. And with the high resolution data, we can monitor tree canopy outside forests for the first time. And it's detailed enough that we can see individual trees and change growth or loss in individual trees. And for the purposes of this data set, areas over 1 acre in size were considered forest. And there were some other criteria like the width of forest areas, and this forest definition is tied to the Forest Service FIA forest definition, which also uses a 1 acre minimum size threshold, and some other metrics related to the ground sampling. So the high resolution data is the one data set out of the 3 that can examine trends in tree canopy outside forest. And this is a view of the NAPE imagery used to create the high resolution data. Then in terms of analyzing the data, we were looking at key Maryland forest legislation, and I'm highlighting the 3 probably most important laws or agreements here. First, the Forest Conservation Act of 1991. This requires a forest management plan when development takes place. It covers all of Maryland except for the 2 westernmost counties, which were exempted because they have high forest cover. And it sets goals for requiring retention of important forest areas within a development, as well as having requirements to mitigate forest loss through either tree planting or other practices described in the legislation. And it's carried out by local jurisdictions. The Forest Preservation Act of 2013 first set a goal for achieving no net forest loss, and also a goal of achieving 40% forest cover across the state. And then the Chesapeake Bay Agreement of 2014, these are the guiding principles for Chesapeake Bay restoration across the entire watershed. And under this, Maryland has a watershed implementation plan where goals are set for tree planting and restoration, which includes establishing forested riparian buffers on agricultural land and increasing urban tree canopy. So looking first for trends in forest and tree canopy over time, I want to look at the FIA data because it's our longest term data set, nearly 90 years of data nationally. And what you can see here in this top line, which is the total amount of forest land in the state, is you see steep declines in forest cover in the 1960s and 70s with expansion of population into rural areas. And you see these rates of loss lessen over time to the present day, where we're largely seeing a stabilization of forest cover across the state. And you can see this within the last several years of data collection. And also note that this is the one data set that has error bars associated with the data collection, and the rate of change within Maryland is within that error estimation of the state. So FIA reports for the state state that forest change is largely stabilized across the state, and the amount of forest cover is largely stable over time as well. And then the FAA data also collects data on timberland, and these are the subset of forests that are managed for timber, wood, pulp and paper production, and other forest products. And In all, the amount of timberland across the state has been declining, but there still is significant activity both in hardwood and softwood management across the state. In terms of regional patterns of forest cover, the greatest amount of forest cover is in Western Maryland and also Southern Maryland. And especially in Western Maryland, you see a low portion of the forest cover in tree canopy outside forest. Most of the tree canopy is within forest. And then conversely, in North Central Maryland and Central Maryland, we see a much higher portion of tree canopy cover in trees outside forest and a lower overall amount of forest cover. And then looking at Eastern and Southern Maryland, there's a greater amount of forest and agriculture, especially on the Eastern Shore, and also significant areas in wetlands as well, especially tidal wetlands. This is a really important table for understanding the key messages in the report. And I first want to highlight different forest extent measures that range from 2.5 million acres across the state with the FIA data up to 3.1 million acres with a high resolution data set. And it's really important to note here that because of the way the data is collected, whether field sampling targeting forests specifically or increasingly higher resolution satellite monitor, these data streams see different amounts of total tree canopy with the most probably complete view with the high resolution data, but they're also have observations over time. And so we really urge that it's important to look at, FIA forest trends across time, NLCD across time, and CBPO data across time as well, rather than comparing the absolute amount of forest and tree canopy observed. And then with all of the CBPO analysis, we broke observations down into the estimated amount of forest in the state using these definitions I mentioned. It's tied to the FIA, so you see this similar 2.5 million acres, and then we have just over 500,000 acres of tree canopy outside forest, which none of the other data streams completely cover. And then looking at trends over time, with the FIA data, we saw that an overall 4.6% decline. But as I showed you in that previous chart, the rate of loss has really leveled out and stabilized in more recent years. Over the 2001 to 2019 time period, there's an annual rate of change of negative 0.23%. With the NLCD data, it sees a smaller rate of annual forest loss and overall loss. Some of this may be due to the increased area of total forest and detecting some tree canopy outside forests. And then with the high resolution data, we saw over a 5-year time period a decline of negative 0.39% and an annual rate of negative 0.07%. So what we see here is that all 3 data streams estimate that forest is the amount of forest in Maryland is still declining, although that rate of decline has really stabilized over time and is growing smaller as time goes forward. So in terms of forest health, as I mentioned, we looked at fragmentation and invasive species. Our fragmentation analysis found that Maryland's forests are largely, there is a high degree of fragmentation, and that forest cover is very patchy, especially in more developed parts of the state. And that we see a trend in the data of increasingly reduction of forest areas from the large core areas to medium, small, isolated patches, and then isolated patches being divided further into areas that are too small to reach the forest definition threshold. And the strongest amount of, or the greatest amount of fragmentation is happening in central Maryland, which also had the greatest amounts of forest loss. And these trends are really important. Part of this is because increasing fragmentation of forest makes it more susceptible to invasion by invasive species. And these invasive species include Oriental bittersweet, Chinese wisteria, other invasive vines that can actually kill tree canopy or prevent tree canopy from forming. And FIA data was the only data set we had that evaluated invasive species systematically across the whole state. And their analysis found 12% of forest land had evidence of large-scale disturbance, and the leading cause of these disturbances was suppression by invasive species. And there's more detailed data on specifically what species in the full report. We looked at progress on Chesapeake Bay restoration, and we looked at two different types of metrics. First, the Bay program overall has a goal of having 70% tree canopy coverage in riparian forest buffer areas by 2025. This is because forest and tree canopy are one of the most effective ways of filtering sedimentation and nutrient pollution from waterways. And what we found across Maryland is that our average coverage of riparian areas with forests is 58%. We saw progress, but not fully reaching that 70% goal. But I do want to also note that there was very large variation. Allegheny County had the highest percent, 79% of riparian buffer areas forested, and Somerset had the lowest at 26%, but particularly in Eastern Maryland and on the Eastern Shore, these areas have a lot of land in tidal wetlands and other areas where it's not possible to establish forest cover in riparian areas. So that 70% goal might not be appropriate for some of these counties. We do have a lot more detailed statistics in the full report on both like how each county is progressing towards this Bay-wide general goal of 70% forest cover, but also on their specific county goals and state goals. And then overall, we saw a substantial net loss across the state of urban tree canopy, and that was especially in Montgomery and Prince George's County. We used the census urbanized area data set to evaluate this. And we did see gains in some urban jurisdictions. Baltimore City had tree canopy gains, and then some of the smaller urban areas, especially in Eastern Maryland, had significant gains as well. And this is the first time that we've been able to comprehensively look at urban tree canopy across the state, or all tree canopy outside forests, which also includes agricultural areas. So some evaluation of this will depend on having more observations over time with this data. The next high resolution data will come out in 2024 and will cover the 2020-2021 time period. We looked in land cover and land use transitions, both with the moderate resolution NLCD data and with the high resolution Chesapeake Bay Program Office data. And the key take-home messages that we saw was, so what you're seeing in this chart is on the left side are all of the classes at the first time step, which for NLCD was 2001. And that had changed. So forest was the land cover classification that had the most change. 38% of change came in from forest areas. And then on the right, this is the resulting class in 2019 of those same areas, and developed areas were the largest resulting class. So developed land came both from forest and from agriculture. And then there are a lot of dynamics with forest overall related to both forestry and natural disturbances. And with the high resolution data, we saw similar patterns. Nearly 50% of all areas that changed in 2013 came from forest areas, and 38% of the resulting land use classifications were in developed land classes. Looking at change on a regional basis, we looked at both forest dynamics and tree canopy outside forest and found that the greatest amount of change was in Central Maryland. And Central Maryland was also the only region that saw net tree canopy change outside forest decrease as well as forest. And I know I just mentioned that we saw urban tree canopy decline across the whole state. When we're looking at the county scale with tree canopy outside forest, we were also looking at tree canopy in agricultural areas where we did see an increase. So looking regionally and countywide, we see a net increase in tree canopy outside forest that reflects increase in tree canopy seen in agricultural areas. And some of that net increase is also related to forest fragmentation, where some forest areas were broken into sizes too small to meet the minimum size of a forest threshold. Okay, and then another analysis we did related to change was looking just at changes related to development. And for these, we isolated the changes from forest and tree canopy into impervious surface classes. So that's roads, structures, driveways, parking lots, and then also low vegetation in the form of turf grass. So we combined these two types of developed areas to look at overall changes. And again, well, the significance of changes related to development is that these are considered permanent changes in forest land use, even though the amount of tree canopy in these areas can change over time. And these changes are really focused especially in Central Maryland and the most rapidly growing regions of the state. We also analyzed forest and tree canopy change associated with development at the county scale. And we found that Prince George's and Montgomery County combined made up 44% of the statewide change associated with development. And then the top 6 counties, nearly 70%. So this really underlines the message that tree canopy changes associated with development are really focused on the rapidly growing portions of the state. We looked at tree canopy commitments on tree planting and also new legislation like the Tree Solutions Now Act, which has a goal of planting an additional 5 million trees. This could result in a total of, we estimate at a rate of 400 trees per acre, over 12,000 acres of tree canopy gain. And there's also been additional statewide efforts to identify restoration opportunities and other urban tree canopy planting goals that Dr. Dubé from the Hughes Center will go into in more detail. We looked at protection, and Maryland has been rapidly increasing the amount of land that's protected across the state, noting that in 2018, 26.9% of land was protected in the state. This increased to 29% in 2021. And Maryland is really on the cusp of achieving the 30 by 30 goals for overall land protection. This includes protected areas that are publicly owned, as well as easements on private land in the form of conservation easements and agricultural easements. in protected areas, we also, not only did we see a much slower rate of forest loss in protected areas, we saw a significant amount of tree canopy gain in protected areas. And I think this is a really key message for the study, that protected areas not only retain forests, but they are a source of forest and tree canopy increase. We mapped out, we created a new data set derived from the high resolution data on plantable areas, where trees and forest canopy could be established. And this data set is made available and downloadable for the state, and could be very useful at the local level for setting appropriate goals based on where opportunities are, and focusing tree planting activities on the areas either with the greatest amount of opportunities, or assessing how much plantable area there are in different categories. For example, like publicly owned land, like schools or playgrounds and the like. We found the greatest amount of tree planting opportunities in Baltimore, Montgomery, and Prince George's County. And these opportunities were made up of, low vegetation, lawn, turf, barren lands. And for this analysis, we did not include agricultural lands because we addressed those separately in the Chesapeake Bay program goals. So there are different data products that are focused on agricultural planting opportunities. So with that, I am going to transfer to Dr. Addie Dubé with the Hughes Center, and she's going to focus on our key findings on mitigation and tree planting programs. So Addie, I'll turn it over to you.
Excuse me, before we do that real quick, a couple of people asked the same question that I think would help continue to frame this. We're not going to answer all the questions right now. For those of you on the line, thank you for asking questions. We will reach them at the end of the presentation, but this one in particular, a couple of people are asking. So I wonder, Susan, if you could clarify the definition used for forests. Specifically, both of them are talking about canopy, density, size, and age.
Yes. So so a lot of these specific metrics at the county scale are done with the high resolution data, because as I mentioned, it's not possible with the FIA data to examine sub-state patterns. So for the high resolution data set, there was a minimum patch size for forests, so areas of at least an acre in size. And then also a minimum width for forest area. So at least some part of the forest patch, I believe it was 240 meters wide. So, and there's some additional criteria that are listed in the report. But essentially what this means is all urban and suburban tree canopy is mainly in tree canopy outside forest, but like large urban parks can be forest. And when you're looking at agricultural lands, where like riparian forest buffers, those are primarily tree canopy outside forests. So does that?
Mm-hmm. Yes, that answers those questions.
Yes, yeah, and I do see the question too on looking at forest and tree canopy. There is a portion of the gains in tree canopy that are related to fragmentation of forest into tree canopy outside forest, but we did specifically identify tree canopy outside forest gains in both agricultural and protected areas. So I wanted to mention that as well.
Great, thank you, Susan.
Okay.
Go ahead.
So Addie, I'll hand it over to you for the mitigation and tree planting programs.
Perfect. Thank you, Susan. So I'm going to jump right into task 6, which was forest mitigation banking in Maryland. And I'm going to start with some brief background information and then address each of the questions that we were asked to look into for the report. So the FCA has reforestation or afforestation requirements for development projects in order to mitigate forest loss in the state. And afforestation is usually in cases where the property being developed has very low or no tree cover to begin with. So there's several different options for that. And there's a preference order starting with on-site mitigation, followed by different types of off-site mitigation strategies. And finally, if neither of those is feasible, then the developer can make a fee in lieu payment to the county instead. So purchasing credits from a privately owned forest mitigation bank is one of the off-site options available to developers. Traditionally, there have been two types of banks in the state: planted banks, where the landowner specifically plants trees for the purpose of the bank, or retention banks, where they conserve existing trees on their property. However, retention banks have been phased out by House Bill 991, and new ones have not been permitted since 2021. So the first specific question was about the regulation of the siting and location of forest mitigation banks. And these are regulated on the county level. However, the FCA does outline criteria for priority locations for banks in order to maximize the ecosystem services provided by forests. Some examples include riparian buffers, steep slopes, and 100-year floodplains. The next question was about the capacity and location of active banks. And here we're basically looking at which counties in the state have banks and which ones don't. So in green, Garrett and Allegheny County are exempt from the FCA because of their existing high forest cover. The counties in purple, as well as Baltimore City, do not have any provisions for forest mitigation banks, so that is not an option in those places. The ones in yellow do have a provision for banks, but no banks have been established there as of yet, so they're meeting those mitigation requirements through other methods. And finally, all of the remaining counties do have banks, but the ones in white, we were not able to get complete data on their acreage and types. So in total, we estimated about 17,258 acres of banks in the state, of which 4,748 were active or available for the purchase of credits at the time of our survey, but that number changes frequently over time as credits are purchased and new banks are established in various counties. The next question was comparing the proportion of planted banks versus retention banks in the state. So here we just focus on the counties for which we have data that have banks. And you can see in green, Carroll County is the only county in the state that has never allowed retention banks. They have only had planted banks from the beginning. The ones in purple only have retention banks, though that will obviously change moving forward now that retention banks are no longer permitted. And the ones in blue have some combination of both. However, even in the counties that have both, retention banks still tend to be more dominant. And overall, about 81% of the total acreage of banks in the state was retention, compared to about 19% that was planted. The next question was about the market for banking and whether there's a relationship between that market and fee in lieu rates. So we did not observe any relationship here. It's important to keep in mind that banks are only one of several different mitigation options available to developers, and there's no reason to think that banks in particular would have a strong relationship with fee in lieu compared to any of the other mitigation options. Additionally, there's only 12 counties that have both banks and the option of making a fee in lieu payment, and the majority of them simply use the rate for fee in lieu that's outlined in the FCA with occasional increases for inflation. So that's not something that's changing frequently in response to any type of market pressure. The next question was the effect of retention banks on the no net loss of forest policy in the state. So we did pose this question to the employees of counties that have retention banks who we were surveying, and they did not feel that they had the necessary information to answer this question. And this would be very challenging to calculate, especially if we thought about it on a statewide level, because every county has different rules and regulations and requirements when it comes to the mitigation and banks. And as I mentioned earlier, in some cases, credits may be purchased for afforestation rather than reforestation, adding an additional layer of complexity. It is worth keeping in mind that while this is an important question, ultimately banks comprise less than 1% of the total forest cover in Maryland. So whatever impact we're seeing of retention banks, it is on a fairly small scale overall. The final question for this task was whether forest mitigation banks have the potential to improve water quality in watersheds in the state. So generally speaking, afforestation is associated with water quality improvements, especially afforestation in riparian areas. And riparian buffers are a priority area for the creation of forest banks in the state. However, we would only expect to see this potential benefit from planted banks rather than retention banks, since in the case of retention banks, no afforestation is actually taking place. So moving on to task 7, here we are looking at tree planting programs in Maryland, specifically a programmatic and funding review of federal, state, and local tree and forest planting programs. We surveyed data specifically for 2018 and 2019. And as Susan mentioned earlier, we estimated a total of about 1,854 acres planted in the state over those 2 years at a rate of 400 trees per acre. Over half of this was planted through Forest Conservation Act mitigation efforts, and the others through a combination of private and public planting programs on all levels, ranging from federal programs like CREP and EQIP to state programs like Backyard Buffers and Tree Mendus Maryland, and finally county and municipal programs as well. This number is likely an underestimation of the total number of trees planted, because only about 20% of the municipalities in the state responded to our request for information, and we were not systematically reviewing private efforts. And of course, I also want to mention that these trees planted will not show up in the tree covered data that we had in the earlier tasks, because it's going to take a few years before they're mature enough to show up in that. And in general, we weren't really able to draw any broad conclusions or directly compare these programs to each other, because there's just a huge range in their scope and their scale. For example, one of the largest in Baltimore County spent $1.7 million on planting 14,000 trees, whereas one of the smaller ones in College Park was a homeowner reimbursement program that spent about $1,800 on 19 trees. So there's a huge range of what these programs are doing. Finally, some recommendations for tasks 6 and 7. It's pretty clear, given the prevalence of retention banks so far and the fact that they're no longer permitted, that counties and the state will have to come up with new strategies to encourage the creation of planted banks moving forward. One example could be helping landowners with the initial investment, because planted banks require much larger investment from landowners compared to retention banks. And although they can set their own prices for credits, it can often be several years before they're able to start selling credits and recoup their investment. We would also recommend more uniform collection and better availability of banking data, which was challenging to track down in some cases. And that would make it easier to track these important questions moving forward. We would also recommend making information about how to set up banks and purchase credits more widely available to the public as well, to generate more interest and awareness amongst landowners who might be interested in setting up banks on their property. A great example is the Montgomery County website, which provides all of this information in a really easy to find and accessible way. And on the right here is a map from that website showing the locations of banks in the county. Finally, for tree planting programs, again, we recommend more centralized tracking of tree planting data and easier availability. And that data is going to be tracked by MDE moving forward as per the Tree Solutions Now Act, which we support. And with that, I will pass it back to Susan to do overall conclusions.
Okay, great. Thanks, Addie. And before I get started on the conclusions, I did want to mention one thing is that we do have a map viewer available for the study. And if you visit the website for the product at chesapeakeconservancy.org/MD Forest Study 2022, we have the executive summary there. We have links to download data, and we also have an interactive map viewer where you can look at some of these different data products we've been discussing in the study. And so that can really answer the question of like what's happening in your local area. So we encourage people to view that data and download and use the data sets produced in the study. So in terms of overall conclusions, we found the rate of forest loss in Maryland has changed from rates of significant decline towards stabilization since the Forest Conservation Act of 1991. But however, forest loss for development and forest fragmentation continue to be significant trends, especially in central Maryland, although there is regional variation across the state. The state has a significant opportunity to transition from forest and tree canopy loss to gain. Related to that, first of all, we've noted that with tree planting, it can take, we estimated, from 5 to 15 years before newly planted trees are going to be visible and measured in the forest monitoring data. But current growth of current forests and tree canopy outside forests can be seen immediately. So in terms of what we see from our data analysis, what the key opportunities are is investment in tree planting and progress towards the Chesapeake Bay Watershed Agreement goals are playing an important role. And in addition, statewide legislation like the Tree Solutions Now Act of 2021 provides additional investment funding and goal setting related to tree planting and forest restoration. And then protection of forest is important for two reasons. First, avoiding loss of existing forest and tree canopy, but secondly, can also be a source of tree canopy gain, as increased tree planting happens within protected areas. And these include public protected areas as well as areas under forest conservation easement or agricultural easements. And this is also an area that the state has been making significant investments in, that is a significant opportunity to increase or tip the balance towards tree canopy gain across the state. And then we had some key recommendations that are related to data products and data collection. The high resolution monitoring of forest and tree canopy offers a lot of opportunity to measure and monitor, especially tree canopy outside forest for the first time, but that the state should continue other monitoring streams like using federally funded data streams like the NLCD and the Forest Service FIA field sampling inventory data, and using the combination of data sets is really important towards increased understanding of trends. And I also wanted to just mention here briefly is that the state has also been developing a forest carbon monitoring system, and that should be available in the near future and will provide a fourth stream of forest monitoring information. And then Addie pointed on the importance of standardized data collection on mitigation, banking, and tree planting efforts to be able to collect that data in a systematic way across the state. And that's especially important in terms of identifying progress ahead of when those growing trees are going to be visible in the data. So that concludes our presentation. We're going to transition now to a question and answer session. And I just want to, issue a thank you to the Hughes Center for this project and to the greater project teams in the advisory committee for contributing to the results and all of the great information this provides. Thank you.